Hello children, we are going to see about continuity. Before that, we will see what is the limit, left hand limit, right hand limit, which we learnt in class 11. So limit, consider the function f of x equal to x square. Observe that x takes values very close to 0. The value of f of x also move towards 0. We say that limit x tends to 0, f of x equal to 0. We can read this as limit of f of x as x tends to 0 equals 0. The limit of f of x as x tends to 0 is to be thought of as the value of f of x should assume at x equal to 0. In general, as x tends to a, f of x tends to L, where L is called the limit of the function f of x, which is symbolically written as limit x tends to a, f of x equal to L. There are two ways in which x could approach a number a, either from left or from right. That is, all the values of x near a could be less than a or could be greater than a, which naturally leads to two limits, the right hand limit and the left hand limit. So right hand limit of a function f of x is that the value of f of x, which is dictated by the values of x when x tends to a from the right. Similarly, the left hand limit from the left in which x tends to a. Consider the function f of x, which is equal to 1 if x is less than or equal to 0, and f of x equal to 2 if x is greater than 0. It is clear that the value of f at 0 dictated by the values of x at x less than or equal to 0, which is equal to 1. Then x is less than or equal to 0, then f of x is 1. That is, the left hand limit of f of x at x equal to 0 is limit x tends to 0 minus, it is denoted by, left hand limit is denoted by x tends to 0 minus f of x, which is equal to 1. To the left of f of x, that is x is less than or equal to 0, it is 1. So limit x tends to 0, f of x equal to 1, which is the left hand limit. Similarly, the value of f at 0 by the values of f of x when x is greater than 0, it is equal to 2. The right hand limit of f of x at x equal to 0, the value is 2. So right hand limit x tends to 0 plus. So right hand limit is denoted by plus f of x equal to 2. The right hand and left hand limits are different. We say that the limit of f of x as x tends to 0 does not exist even though the function is defined at 0. We say limit x tends to a minus f of x, which is the expected value of f of x at x equal to a, gives a value of f near x to the left of a, and this value is called the left hand limit of f at a. Similarly, the right hand limit, which is to the right of a, if both left hand and right hand limits coincide, we can say that the common value of limit of f of x at x equal to a, and it is denoted by x tends to a, f of x, if both left hand and right hand limit coincide. So we can see from the graph that the value of the function at nearby points on x-axis remains close to each other except at x equal to 0. At the point near and to the left of 0, that is the points like minus 0.1, minus 0.01, minus 0.001, the value of the function is 1. At the point near and to the right of 0, the points like 0.01, 0.001, the value of the function is 2 when x is greater than 0. When x is less than or equal to 0, it is minus of 0.1 minus 0.001. But the value of f of x is 1. For x is greater than 0, the value of f of x is 2. If the points are 0.1, 0.001, etc. Consider the function defined as f of x equal to 1 if x is not equal to 0 and it is equal to 2 if x is equal to 0. This function is also defined at every point left hand right hand limit of x equal to 0 or which are both equal to 1. But the value of the function at x equal to 0 which is equals to 2 which does not coincide with the common value of the left hand right hand limit. We know that we cannot draw the graph of the function without lifting the pin, which is an instance of a function being not continuous at x equal to 0. We may say that a function is continuous at a fixed point if we can draw the graph of the function around that point without lifting the pen from the plane of the paper. If the left hand limit and right hand limit and the value of the function at x equal to c exist and equal to each other, then f is said to be continuous at x equal to c. If the right hand and left hand limit at x equal to c coincide, then we say that the common values is the limit of the function at x equal to c. So the definition of continuity is a function is continuous at x equal to c if the function is defined at x equal to c, if the value of the function at x equal to c which is equals to the limit of the function at x equal to c. If f is not continuous, then we say that f is discontinuous at c and c is called a point of discontinuity of f. A real valued function f of x is continuous at a point a in its domain if limit x tends to a, f of x which is equal to f of a. If the left hand limit, right hand limit and the value of the function, that is limit x tends to a minus which is a left hand limit and the right hand limit x tends to a plus f of x and the value of the function at x equal to a exists, that is f of a, and are equal to each other, that is limit left hand limit which is equal to f of a which is equal to right hand limit, then f of x is said to be continuous at x equal to a. If the function f of x is not continuous at a point a in its domain, we say that f of x is discontinuous at a and a is called a point of discontinuity of f of x. Continuity in an interval. So whether it is an open interval or closed interval. F of x is said to be continuous in an open interval a comma b if it is continuous at every point in the interval, in this interval. Then f of x is continuous in the closed interval a comma b if it could satisfy the three conditions. If it is in the closed interval, if f of x is continuous in open interval a comma b and limit x tends to a plus, that is right hand limit f of x equal to f of a and limit x tends to b, f of x equal to f of b, left hand limit which is equal to f of b. Then we can say that f of x is said to be continuous in the closed interval a comma b. Algebra of continuous function. So suppose f and g be two real functions continuous at a real number c, then f plus g is continuous at x equal to c. So sum of the functions which is continuous and difference of the function which is continuous, the product of the functions and the quotient of the continuous functions are continuous if f of x and g of x are continuous function on the common domain. Continuity of f plus g of x at x equal to c. It is defined at x equal to c. We have a limit x tends to c, f plus g of x which is equal to limit x tends to c, f of x plus g of x. So by the definition of f plus g of x, which is equal to f of x plus g of x, this can be written as sum of two limits, limit of x tends to c f of x plus limit of x tends to c g of x, which is equal to, since it is continuous at c, this can be written as f of c plus g of c, as f and g are continuous, which is equal to f plus g of c. So we can say that f plus g is continuous at x equal to c. So remaining parts are similar. So it could be done in a similar way, like limit x tends to c f minus g of x, and the product and the quotient of the two real functions. Exercise 5.1. Prove that the function f of x equal to 5x minus 3, which is continuous at x equal to 0. Given function f of x equal to 5x minus 3 at x equal to 0, f of 0 is, substituting x as 0, then 5 into 0 minus 3, which is minus 3. Then we need to find left hand limit and right hand limit. If left hand limit, which is equal to right hand limit, which is equal to f of x, then it is said to be continuous. Then finding left hand limit, limit x tends to 0, f of x equal to limit x tends to 0 minus f of x is 5x minus 3, substituting as 0, then we get minus 3. Then right hand limit, limit x tends to 0 plus f of x equal to limit x tends to 5x minus 3, substituting value of 0, then we get minus 3. Therefore, left hand limit, which is equal to f of x, which is equal to right hand limit, then we can say that the function f is continuous at x equal to 0. Now we have to prove that the function f of x equal to 5x minus 3 is continuous at x equal to minus 3. So first step, f of minus 3, put x equal to minus 3, then 5 into minus 3, which is minus 18. Now we have to find left hand limit, which is f of x limit x tends to minus 3 minus, which is equal to limit x tends to f of x is 5x minus 3, substituting value, then we get minus 18. And right hand limit, we get limit x tends to minus 3 plus 5x minus 3, which is equal to 5 into minus 3 minus 15 minus 3, which is minus 18. Here LHL equal to f of x at x c, which is equal to right hand limit. Then we can say that f is continuous at x equal to minus 3. We can write this as f of c. Then we can say that f is continuous at x equal to minus 3. Now we have to prove that f of x is continuous at x is equal to 5. So f of 5, substituting, then 25 minus 3, which is 22. Then left hand limit, which is limit x tends to 5 minus f of x is 5x minus 3, which is 22. And right hand limit, which is equal to limit x tends to 5 plus 5x minus 3, which is also equal to 22. Then we can say that the function f is continuous at x is equal to 5. Second question, examine the continuity of the function f of x equal to 2x square minus 1 at x equal to 3. So similar way, given function f of x equal to 2x minus 1 at x equal to 3, then f of 3 is 2 into 3 square minus 1. So 18 minus 1, which is 17. Then left hand limit x tends to 3 minus f of x. F of x is 2x square minus 1, which is again 2 into 3 square minus 1, which is 17. And right hand limit, which is equal to limit x tends to 3 plus f of x. F of x is 2x square minus 1. Then again substituting, we get 17. So all the values are 17. Left hand limit, which is equal to right hand limit, which is equal to f of c. Hence the function f is continuous at x equal to 3. Third question, examine the following functions for continuity. So first part, f of x equal to x minus 5. So for the 1 and 2 questions, they are given some point in which we have to check the continuity of the function. In these questions, we don't have any point given to check the continuity. So we have to check the continuity in the domain. So if we have any real numbers, the answer will be the real number. So domain is any real numbers. Let k be any real number at x equal to k. So f of k equal to k minus 5. So if we substitute any real numbers, the answer will be the real number. Then left hand limit x tends to k minus f of x, which is equal to limit x tends to k. F of x is x minus 5, so k minus 5. Here we can see that f of k and limit LHL is same. Again RHL is limit x tends to k plus f of x is x minus 5, which is equal to k minus 5. So we can see that f of k, LHL and RHL, which are same. So we can say that the function f is continuous for all real numbers. So C subdivision, f of x equal to x square minus 25 by x plus 5, x is not equal to minus 5. So domain is all real numbers except minus 5. It's given that x is not equal to minus 5. If it is minus 5, then it will become 0. So except minus 5, the domain will be all the real numbers. Let k be any real number. Let k belongs to real numbers except minus 5. So f of k is substituting here k square minus 25 by k plus 5. So using the identity k minus 5 into k plus 5 whole by k plus 5. So cancelling this, we get k minus 5. Then left hand limit, which is limit x tends to k minus f of x. F of x is x square minus 25 by k plus 5. So same thing, which is k minus 5 into k plus 5 whole by k plus 5, which is equal to k minus 5. Then f of k equal to left hand limit, both are same. So we can say that f of x is continuous at a point k, which is real number except minus 5. So f of k and limit x tends to k, in which it both gets a k minus 5 and k minus 5, which are same. Both f of k, which is equal to limit x tends to k. So f of x is continuous at a point k, which belongs to our real numbers except minus 5. Fourth question, prove that the function f of x equal to x power n, which is continuous at x equal to n, when x is a positive integer. Here we have to prove that f of x equal to x power n is continuous at x equal to n. So f of n equal to n power n. Then limit x tends to n, f of x, which is equal to limit x tends to n, x power n, which is n power n. If you take any values for n equal to 1, 2, 3, etc., we get, then we will get 1 power 1, 2 power 2, 3 power 2, etc. So we get n power n. If you take any values for n, then we will get the same real numbers. Here we can see that f of n and limit x tends to n f of n is same, which is n power n. Here we can see that f of n and limit x tends to n f of x, which is n power n, in which both are same. So we can say that f of x is continuous at x equal to c. Fifth question, is the function f defined by f of x equal to x if x is less than or equal to 1, which is equal to 5 if x is greater than 1, is continuous at x equal to 0, at x equal to 1 and at x equal to 2. We have to check the continuity at 3 points. So first at x equal to 0. So f of x equal to f of 0, which is equal to, so first at x is equal to 0, that is less than 1. If you take any number line, so 0, f of x at x equal to 0. So x equal to 0, here it is x is less than or equal to 1, we have x, and x is greater than 1, we have 5. So we have x is equal to 0, which is less than 1. So we have to take this function f of x equal to x. So f of 0 is 0. So then limit x tends to 0, f of x. Here x is, f of x is x. So limit x tends to 0, x, which is equal to 0. Here we can see that f of x and limit x tends to f of x, which is 0. Then we can say that f of x is continuous at x is equal to 0. Now we have to check for point x equal to 1. So f of 1 is 1, that is f of x equal to x. So f of 1 is 1, then right hand limit, which is limit x tends to 1 plus f of x, which is equal to limit x tends to 1 plus, then right to 1, which is 5. So limit x tends to 1 plus, which is 5, which is 5. Then left hand limit, which is equal to limit x tends to 1 minus f of x, which is to the left of 1. That is, we get the function x, which is less than 1. X is less than 1. Then limit x tends to 1 minus, which is x, which is equal to 1. Here we can see that f of x is 1, right hand limit is 5, and LHL is 1. So we can say that LHL is not equal to RHL, which is not equal to f of x. Then we can say that f of x is discontinuous at x equal to 1. At x equal to 2, we have to check the continuity of the function. So f of x equal to f of 2, which is equal to, that is x is greater than 1. So we have to take 5. So f of 2 is 5. Then limit x tends to 2 plus of f of x. So right hand limit, then this is equal to limit x tends to 2 plus. So the function which is greater than 1, it is defined to be 5. So which is equal to 5. Even LHL, limit x tends to 2 minus f of x, which is equal to limit x tends to 2. It is defined to be 5. So which is equal to 5. We can see that LHL equal to RHL equal to f of c. So we can say that f of x is continuous at x equal to